Hello, everyone. As Rochelle mentioned, my name is Karishma Panwani, and I'm the Director of Product Management for Maplesoft's Academic Product Suite. So as the product manager, you won't be surprised when I tell you I spend a lot of time talking to educators and math education researchers. But I try not to do most of the talking. What I do is I ask questions and I listen. And so why do I do this? We do it, or I do it, I should say, because our goal with Maple Learn is to help create a utopian world where all students love math. A world where math is for everyone, not just the gifted. And a world where the purpose of math class at every level is to explore and marvel at the wonders of the universe, not to get the correct answer. And I know that the only way we're ever going to achieve this goal, this vision, is if we ask good questions of educators who are facing these challenges every day. So today I share the 3 questions that I keep asking. Number 1, where does math anxiety come from and what can we do about it? Number 2, how do we keep students engaged and interested in math when they're pulled by so many different demands, competing demands on their time and their focus? And 3, how do we support educators who share in our dream? Now, for each question, I'll talk about the answers I'm hearing, and I'll show you ways that Maple Learn can help us get closer to this utopian vision. And I really do believe that together, we can help revolutionize the face of math education. So let's get started. Now, this first question is really about combating math anxiety. You know, if our goal is for students to love math, then we need to find ways to deal with and face with math anxiety. So question number 1 is dedicated to both understanding math anxiety and examining how Maple Learn can be an effective tool in combating it. Now, if you type math anxiety into Google, you'll get tons of hits. And math anxiety is really understood to be that stress, that tension that one feels when confronted in, I should say, math-related situations, whether that be in the classroom or at the grocery store. You know, I think of it or understand it as that racing heartbeat and the sweaty palms. Now, the more interesting question, in my opinion, is where does that math anxiety stem from? Now, in my research and my discussion with math educators and math education researchers, there's just not a single source. Now, here's a few that I've encountered. So, math anxiety can be a learned response as a result of that negative precondition or predisposition, I should say, that a young child perceives in their parents or teachers. It's that audible sigh that you can hear when a teacher says it's time for math. Or the phrase that a lot of parents say, and they don't even realize it, math was not my subject, or I'm not good at math. Children hear this, and this can kind of lead towards math anxiety. Another source of math anxiety, based on some of the research, is it can develop as a result of social situations. A child who was chided by their parents or their peers or their teachers for getting the wrong answer. That child can grow up to be a person who hates math. I know many adults who start to panic when they need to calculate tax or split a bill at a restaurant because they can't do the math quickly enough. And so as a result, they're not able to think and they can't even do it at all. Another source of math anxiety that's well written about is, when a student moves from counting and arithmetic to more abstract concepts such as algebra. And that's because the math in an algebra combined with word problems that a student encounters in an algebra course are just more abstract. And the last one on my list, and if you think of others, put them in the Q&A. I'm really interested in learning more about this area, is, it can arise when students haven't developed the foundational skills, the understanding, or even the practice to keep up with their peers as they progress through their studies. And I know this is something that I dealt with personally. As I moved into university, I felt that there were gaps in my understanding and I did struggle, but luckily I had resources and tools and amazing TAs and teachers, and I was able to kind of get back on track. But this can be a source of math anxiety, and it can turn students off towards math or STEM careers, whether personally or again, professionally. So the more interesting thing here then is, how can we resolve these issues? And is there a place for MapleLearn? And the answer is yes and yes, especially for items number 3 and 4. So MapleLearn, as you're about to see, it provides several ways to reinforce foundational concepts, solidify understanding, and make practicing math fun. Now, based on my conversations with educators, being able to visualize an expression or a problem to interact with math is a key to helping students develop an appreciation and deep understanding for what's going on. And that's why MapleLearn was designed to support easy visualization, exploration, and instant parameterization. So let's take a look at some examples. So how can MapleLearn help? Well, it can help through access to digital manipulatives. So here's an example. Now, manipulatives emphasize mathematical understanding over rote memorization. And I was first introduced to algebra tiles by a high school algebra teacher who explained that she used algebra tiles within her algebra class, again, to do that exact thing, to make sure that students actually understood the foundational concepts of what they were doing, as opposed to just memorizing the formula to, in this case, complete the squares. So let me show you how this works in MapleLearn. So in this particular case, I'm going to complete the squares for this first function. So I'm going to go ahead and drag x squared over, and then we need 2x. So I'm just dragging them into place. So MapleLearn provides me with this free-form canvas. Okay, and let me align it just so. There we go. And we need 7 of these. So, oops. There we go. So here's 1, and I can go ahead and let me just duplicate this. 2. So then we need 7. So I have 1, 2, 3. We'll duplicate it. 4, 5, 6, 7. So now I can go ahead and say that x squared plus 2x plus 7 equals, we're going to say over here, if I look at it, x plus 1 squared, and I have 6 tiles left, plus 6. And so I can go ahead and confirm this by, let me just move this, let me open up the panel over here. And you can see over here, I can confirm this through MapleLearn in this, what we call the live plot window. And I can also use the context panel over here and ask MapleLearn to give me the result. Now, the context panel is something that we borrowed from Maple, and we put it in place because a lot of Maple users, a lot of educators really loved it. The context panel over here that you see, it changes. The operations that are available in the context panel change based on your input, expression, function, or equation. So right now I get the answer, and this is one way to use MapleLearn. So let's go back to our slide over here. As I mentioned before, MapleLearn makes it really easy to explore and parameterize different concepts. So I'm going to pull up this example. So this example is kind of getting a student to understand the concept of the vertical line test to determine if, a given relation is a function. So here we have the animation. Let me go and make this plot window a little bit bigger so you can see. And of course I can go and I can change the slider manually. Now, every time I change what we call a group, the plot window updates and I'm able to see the relation, the function plotted over here. Here's another example. And so a student can look at this and, with this expression and say, this is not a function. A student can also go ahead and change this. So let's say they want to look at, instead of the square root of x, let's go ahead at the floor of x. And so notice that this updates. Of course, if I want to stop the animation, I can click on the little cog. I can stop the animation. I can change my values. So let's go from -10 to 10. And here we have it. Now, at any point as an instructor, you can create these documents that you can then share with your students. So for this example, I'm going to go ahead and click on the share link. It's going to create a link in my clipboard, and then I'm going to go to my chat window and I'm going to paste it in here. So this is another example that I wanted to show. Now, I've gone ahead and actually chosen another example because MapleLearn is great not only for your traditional math courses, but for math-based courses such as economics, finance, physics, chemistry, biology, so on and so forth. So this example, again, a great visualization over here to help students understand, conservation of energy in this example, a spring mass system. So right away, students can kind of explore the concept. Notice that MapleLearn does support units as well. So it can really be used in multiple different math and math-based disciplines. Visualization. So this is an area that time and time again, instructors say is really key to getting students to understand a particular concept. A lot of students, it's once they see it, once they can interact with it, that's when the light bulb goes off. So let me show you some examples. Now, as a student, I struggled, really understanding differential equations and understanding that the solution, there could be many solutions to a differential equation. So over here, I'm going to show you 3 related examples, and these examples kind of build on top of each other to help a student understand this concept. So in this particular example, I have an introduction, it just briefly explains what a differential equation is. But I love this example because it says, here you have a differential equation, y prime of x equals y of x. And it asks the student to reflect, to think. So what function satisfies this? What function is equal to its own derivative? And a student can go in and change this value. And notice as they do it, this plot window is automatically going to update. So they can say, well, we know here x and the derivative, which has automatically been calculated. That's not right. A student might try sine of x. No, you can go ahead and zoom in if you want to, so you can see a little bit better over here. Now, a student might play with this, or they may know, well, the answer is e to the x, and we can see from the plot that it's true. So the derivative and the function are equal to each other. In this example, same thing. We're going to look at the differential equation f prime of x equals x, and the student is asked, what function satisfies this? So again, they can go here and change it. They might say, in this case, maybe hopefully they'll say x squared. And then they'll come to realize, well, that's not quite right. They're going to have to divide this by 2. And then they're able to confirm. Of course, at any point, you have the context panel, and you can click on this and get the solution. So over here, we have the solution, the general form of the solution. And similarly, you can do this here. So that's the first example, and that's how visualization in this example kind of supports learning. Let me show you the next example. So this example kind of starts getting students to understand that, you know, the differential equation can have multiple solutions. And over here, we see this vector field, and a student can go ahead and look at the solution for different points of x and y. So let's go ahead and change this. We'll go look at minus 8, I should say, and we'll pick the point 8. And if I click this button, you'll see that the plot will update. Similarly, I can pick something else. And I can go and see the solution. Now, one thing to note is that MapleLearn and Maple are communicate together. So Maple, if you're familiar with it, is one of the most powerful math software tools available. It's used by companies such as NASA and Airbus. There's a bunch of different industries that are using it. But one of the reasons we created MapleLearn, apart from the bigger vision of creating this utopian world where students love math, is because the feedback we got from educators was, we love Maple. It can do so much. It has so much power. But sometimes our students were a little bit overwhelmed with everything that it could do. And so what we wanted to do with MapleLearn is create a product that was really easy to use, that was intuitive, but that also connected to Maple. So this particular example over here is actually been created through scripting. So if you are familiar with Maple, you can actually create a Maple scripts, take advantage of almost all the functionality in Maple, and then deploy that to the MapleLearn environment. So that's what you see on this example, or in this example, I should say. Now let me go back. So here now a student hopefully understands the concept of, okay, well, a differential equation, it can have multiple different solutions, and that solution, the particular solution, is determined once you have initial conditions. So here it is. Again, I have this vector field. I can go ahead and change the slider. Same thing. I'm changing values A and B. And notice over here, the student can see the vector field, and this is the particular solution. And the student might be wondering, well, how do we calculate this? Well, in this case, all we have to do is solve for C1. And that's how we get the solution. And this is how we find the solution to the differential equation, y prime plus x equals y. So that's the power of visualization. Now, another area that I wanted to talk about is, engaging in practice. So success in math is not only about discovery, but it's about practice, and you need both. And I think most educators that I've spoken to would agree you need both. But often, it's hard to encourage students to practice. A lot of the worksheets that a student might get might be perceived to be a little bit dull or boring. So how can we spice it up? How can we get students to practice and reinforce their understanding of different concepts? And so I want to show you a few examples and fun things that you can do in MapleLearn. So this one. I love color by numbers, but you'll often see color by numbers used in elementary class to get students to practice arithmetic. But what we've done here, and MapleLearn supports this, is this idea of, well, can we get a university student who's maybe just starting to understand or learn the concept of differentiation? Can we present them with a practice problem that in this case allows them to look at the form of a function or an expression and determine, which rule to employ first? So in this case over here, we have this grid and I have different colors. So let's go ahead and I'm going to change to black color, and I'm going to go and select all the different tiles that would require us to first evaluate this using the product rule. So I might click on this, and then we have this one, and then maybe a student might click on this one. Notice that each time I'm getting feedback. So here it tells me that I made a mistake, so I can go ahead and change this. So I might say this is going to be the constant multiple, change my color, and select it. I get this right. Of course, the student can finish doing this, and then they can see whether they get a pumpkin or reveal the answer. And you see the solution here, and they can try another one. So this is a great way to, again, inject some fun into something that, like I mentioned before, might be perceived as a little bit dull, although very important. Here's another example that I wanted to show. So in this example over here, this is a volume quiz. So this document is used to help a student, practice finding the volume for different shapes. So over here, they can go, we get a 3D plot, they can look at it, they can go in and say, okay, well, what's the answer? So they might know in this case that the volume over here would be the base, the area of the base, 9 squared, times the height. And they can, of course, click and say, okay, well, check my answer. Great, they got it. At any point, they can go ahead and try another. And it'll generate a different object. They can look, you can click. So here's a sphere, maybe they've forgotten, how do you do this? They could always ask for a hint, or they can click on reveal solution and it'll show them the steps. So this is what the volume of the sphere is, and given this problem, how would you get the answer? So this is another document that's used, again, to help a student practice the particular concept. So moving on. Let's talk about, or let's look at the second question that I always ask. How do we keep students engaged and interested in math given so many competing demands on their attention? So, in speaking with educators over the past several years, in doing some research, these are some of the ideas that I've discovered. Now, this is not a comprehensive list. It's just a few of the things that I've seen. I would love, if, feel free to put it in the Q&A, other ideas that you have. So one was incorporate manipulatives when possible. Explain the same concept in multiple ways because different students learn in different ways. Move towards a flipped classroom. So a flipped classroom is where students watch lectures and complete readings at home, and then they come into the class to work on problems together with their instructor and their peers. Encourage projects-based group problem solving. Ask probing questions before revealing the answer. When problem solving, place greater emphasis on the explanation. Get students to, explain it either through written form or to talk it out over the final answer. And then choose topics and applications that appeal to students' curiosity and interests. So again, how does MapleLearn help? Well, I showed you before some of the manipulatives. So just for the sake of time, I'm going to skip on to some other things. Let's look at the flipped classroom. So I'm going to pull up some of these other documents. So let's say as an instructor, you've gone ahead and you've explained the concept of integration to your students. They've watched a YouTube video maybe that you've created. They've looked at your lecture notes, and now they've come to class and you want to work with them and actually employing some of the things that they've learned, in this case, integration by parts. So you can work on this together. This is very similar in structures to some of the things that I showed you before. This one says, here's the equation, solve this using integration by parts. Same thing, the structure of this document is you can have a hint. So in this case, there's 2 hints. So it says, you know, we don't know the antiderivative, but we do know its derivative. And if a student is still stuck, they might say, okay, here's another hint. Let u equal ln of x, then what is dv? And a student can go and begin to solve this line by line. So they can say, okay, well, u is this. Then they might say, you know, v is equal to x, and then they would continue. Let's say that a student was stuck. They didn't know what to do. At any point, they can click on display solution. It'll give them the solution line by line. They could, of course, then solve the problem and check my work. And we'll see that it'll go through and each one, and it says, okay, you've applied the substitution step. Please try again. This solution can't be further simplified because the student didn't finish. But this is how a student could go and use MapleLearn to solve a problem line by line. So this is one example. And of course, now in the flipped classroom, the student is here with their instructor, with their peers, and they can figure it out together. MapleLearn is great. You can use this share link to go ahead, I should say, and create a snapshot of this document. So if a student is stuck, they don't know what to do, they can share what they've done thus far, and they can share it with their peers, with other students. And those students can get a snapshot of their document. I'm going to open it here so you can see what I mean. I'm going to create this link, and you'll see this opens up. So now a student can go ahead and write notes and annotate this and say, okay, oops, let me regroup. They can add some text. And of course, then they can share it back to that other student. Another one is project-based learning. So this particular document was created by an instructor at the high school level. And this is a series of documents. And the idea over here is exploring the concept of functions, but with something fun. So roller coaster design. So this kind of gives you the an overview of what the student is expected, and each document is linked. So in this case, you know, it says, okay, well, this is step one. These are things you should think about. And you can click on the next step and you can go here. And it says, okay, well, think about this from an engineer's perspective. And you know, what's the starting or ending platform look like? Do you want to have a steep drop? Smooth incline and drop, and then a student can mix and match and create their own roller coaster ride. And we can actually go ahead and see this. They can put it all together. Sorry, what I wanted was the blueprint. So a student can put all of this together, place all of their functions, and then go ahead and show this and submit this to their instructor. Ask probing questions. I love this. And again, I got this feedback from educators. So let me show you this document. So approximating circles with polygons. This was, you can imagine, a big theme during Pi Day. So here we have a regular hexagon is inscribed in a circle of radius 1. Find the perimeter of the hexagon. So this is a great way for students to figure it out. They can, of course, look at the visualization, they can try, and then in this particular document, you can scroll down and it gives you the solution. But a student could try to figure this out on their own. This could then also be something that an instructor does within that flipped classroom environment, and we can discuss it. So in this case, the perimeter is 6. And I'll show this to others. Normally, if I had a poll going on, I would ask people to submit their answers. I'll do that for the next webinar. Here's another document. So I like this one again. So this is looking at inscribed angle theorem. And so here you have a slider. And the question is, what do you notice about angle ACB? So a student would play with this, and hopefully they would notice that the angle is always 45 degrees. And this is a really important concept or an important property when it comes to circles. And this is another way to kind of ask questions and get students to explore, to play. Of course, they can always drag this directly on the plot if they wanted to. We could make this bigger, as I showed you before. Oops, let me change this over here. The student can play. And here's the third one. This is looking at the exterior angle theorem. And over here, there are different questions that you ask. Is the hypothesis correct? So over here, we say we hypothesize that a triangle ABC, which is labeled ABC, the sum of angles is A and B is equal to angle D. And you could go and look at this. And a student can confirm if this, in fact, is correct. And they can use the Canvas area to write their answer, share their result, their thinking back with their instructor. And of course, in this particular case, if they scroll down, it gives some background. And interesting applications. This was a hard one, so I have 4. It was hard to even narrow it down to 4. I like this one. This one is, the 4-column theorem. I didn't actually know this. This was an application that was created by one of our co-op students. And so it says, the 4-color theorem states that no more than 4 colors are required to color the region of any map, so that no 2 adjacent regions have the same color. It was the first major theorem to be proved using a computer and was proved in 1976 by Kenneth Apple and Wolfgang Haken, after many false proofs and counterexamples. And I didn't know this, and I find a lot of students really appreciate some of the background, the history. And of course, this is fun as well. So I'm going to go ahead and share this particular document for those of you in the audience, and you can try it out yourself. So we could go ahead and let's go. And we can shade this as green. I might do red. I actually know the answer, but this is what I first did to find it. And so I was continuing on and I did it. And I thought I was so clever until I got stuck because I had done this. And then I thought, well, wait, I've used all my colors. And so of course you can go and reveal the answer and you can see the solution over here and you can then try another. And so you can get to play with this again. I found this is, again, a really interesting way to get students to be actively engaged in the classroom in learning a particular concept. The birthday problem. Students love this. I found this very interesting as a student. And the birthday paradox states that the probability of a shared birthday exceeds 50% in a group of 23 people. Now, I've spoken to educators who have done this in the classroom, and they've actually first gone ahead and gotten everybody to put down their birthday. They've looked at this and they've said, is it true? Is it about 50%? And then they've gone through the math to solve this. And I like these different examples. Again, a student can work on this. They can see, okay, well, here 50% is at 23, and you can go and change this. And these are all ways that Maple Learn can support an educator in trying to, bring static concepts to life, bring math to life, get a student to be really engaged in learning a topic. Here's another one. So these next 2 I picked because we are still in a pandemic, but I see the light at the end of the tunnel. But while we were in the thick of it, one of the questions that kept coming up that I kept seeing was working with students to model COVID-19. And so there's these 2 different documents that have been created. So this is looking at it in the exponential functions. And then here is the sister document on derivatives of the exponential functions example. And so we can go through this. And again, there's a different slider. And this one tells you, Over here, do you agree with this prediction? Now, just for the sake of time, I'm not going to go into this. I can send you these documents if you're interested. But again, a great way to use technology so a student can play with this in class time or can use it outside of class time to reinforce a different concept. And I'm going to move to, oops, my next slide. Here. How do we support teachers who share the same utopian dream as we do? So MapleLearn comes with an extensive library of lessons, interactive explorations, examples, step-by-step solutions, practice quizzes, project material. The list goes on and on. And we have content from high school to university. It's all in the gallery. Let me show you. Be here, let me click on this, let me load this. Hold on, maybe I have too many tabs open. Let me try, it's also here. There we go. So we have, as I was saying, we have content from high school to university that spans math and math-based courses such as physics, economics, biology, and chemistry. And all of these documents that you see here are ready to use in your classroom. Feel free to take them and just go ahead and use them. All of the documents that you saw in my presentation in this webinar were all from the document gallery. So feel free to just go in and use any of this content. Of course, you can always search. So if I want to look at all of our biology content, I can click on it and we can see over here, I can go ahead and I can open this collection. A big one, calculus. And you can see we have things, this little folder is illustrates that this is a collection. So this is a calculus collection and we have multiple topics over here. So take a look. Because a lot of the times we have content that's available for you to use right away in your classroom. Now, all of the content that I showed you, the content is customizable. And so you can customize the content that you get from the MapleLearn gallery, but you can also use MapleLearn to create your own material. And I would say MapleLearn is hands down the easiest tool to author interactive math documents. It's a great tool to make your static content come to life. And if you ever have questions on how to use MapleLearn, it's fairly intuitive. We have videos online. We also have different training sessions. Our team can get you up to speed, within 10-15 minutes. So that's something to look at. It is very easy to use. Now, as you've seen in the webinar, you can use the platform to do all types of math, as well as generate documents that include formatted text, bullets, images, hyperlinks, and more. And so again, MapleLearn is not just a tool for doing math, it's for putting together and explaining the whole solution. It's creating these rich documents that students can use, share, explore, and kind of explain their rationale and thinking. So, we know that the demands placed on educators today is constantly growing, and it leaves educators with very little time to do much else. And as a result, we've created a team of content experts to help you bring your ideas to life. So if you have an idea of an interactive exploration that you want to create on a particular topic, or an interactive quiz, or you have an idea of a great project, but you don't have the time necessarily to implement it in MapleLearn, talk to us. We're here to help. We can work with you to create the concept, give you a proof of concept, take it from start all the way to finish for you. Because if it's something that you will find useful to your students, I can guarantee that other math educators would find it useful. And ultimately, as I said in the beginning, our goal is to make sure that math is accessible to everyone, that everyone succeeds and loves math. Now, lastly, just let me note that we offer flexible classroom licenses to MapleLearn Premium that gives you and your students unlimited access to the functionality, content, and content sharing. There's volume-based discounts and, of course, access to our content development team. So again, ask us about MapleLearn Premium if you're interested in teaching it and teaching with it and getting your students to actively engage in the platform. Now, if you want to learn more about MapleLearn, I encourage you to visit our website where you can find tons of different information. And also you can try it out yourself. So just go to learn.maplesoft.com and you can go and play with MapleLearn, get a flavor for what it can do. And if you want to have a conversation about how MapleLearn could contribute to your classroom, feel free to get in touch with me. I'm happy to have a conversation, and I guarantee that I'll probably have some questions for you.